And now we're going to move on to alkenes. Alkenes are unsaturated hydrocarbons. That means they have double bonds between the carbon atoms. And so by unsaturated, meaning each carbon can't have 4 unique bonds. There is a double bond there. They follow the formula CnH2n. And so remember our alkanes were CnH2n plus 2. These will just be CnH2n. When we name an alkene, our rules all still apply that we had before. They're numbered starting at the side nearest to the first double bond. The parent compound is named from the longest continuous chain containing the double bond. So just like before, but it has to be the longest chain with the double bond in it. The suffix ene, it's an alkene, is used to indicate it's an alkene. So it says write the structural formula for the following, which we have 3-hexene. I'm going to look at hex. Hex tells me I have 6 carbons. So I'm going to have 1, 2, 3, 4, 5, 6. 3-hexene tells me at the 1, 2, 3 position, I'm going to put in a double bond. Now I need to fill in my hydrogens. This carbon needs 4 bonds. This carbon needs 4 bonds. This carbon already has 3, so he only needs 1. This one has 3, so he only needs 1. 1, 2, 1, 2, 3. 3-hexene. Our second one is 2-methylpropene. But because it's propene, in this case, we don't actually need this 2 in here, so we can remove that. And we can just look at it being methylpropene. Propene tells me there's 3 carbons, 1, 2, 3. The double bond doesn't matter which side it's put at, because either way, it's the closest here. And then the methyl group, I wouldn't be able to put it on either of these ones because it would just turn it into butene if I put it on the end at either case. So it has to go on this middle one. And this is sort of unique to propene that we can do this. And so that needs 4 bonds. That needs 4 bonds. This carbon already has 4 bonds. This one has 2, so it's going to get 2 more. Okay, so we'll call that methylpropene. And let's try 4-propyl 4-octene. Octene, let's always start with our parent chain. 1, 2, 3, 4, 5, 6, 7, 8 for octene. Which means at the 4th carbon, 1, 2, 3, 4, I have a double bond. It also has 4-propyl. 1, 2, 3, 4. I'm going to go ahead and put a propyl group, which is 3. So 1, 2, 3. And then fill in my hydrogens. 1, 2, 3, 1, 2, 1, 2. This guy already has 4 bonds, so he's done. This has 3, so we're just going to put 1. This has 2, needs 2, needs 3, needs 2, 2, 1, 2, and 3. We have alkynes, which are the same type of thing. They're unsaturated hydrocarbons, but they have triple bonds between the carbon atoms. They follow the formula CnH2n minus 2 because we'd have triple bonds. They use the suffix YNE. We're going to name them exactly how we name the alkenes. We also have hydrocarbons that are circles, that are cyclic. And so we have cycloalkanes, which is CnH2n. Because they're joined all the way around in a circle, that's where that extra 2 hydrogens go. So we're going to draw the following. We have cyclohexane, so we're going to draw 6 carbons in a circle. And I'm going to draw it up here just so I make sure I have enough room. So this is my first one will go up here. 1, 2, 3, 4, 5, 6. So we draw this sort of octagon shape, and then I can go in and add in all of my extra hydrogens that are needed. Okay, so I have cyclohexane. Then I have ethyl cyclohexane. So I'm going to draw that same cyclohexane, although I could probably just add on to this one. This is cyclohexane, so that's our first answer. Now, ethyl cyclohexane, we're just going to pick one of the carbons because whatever one that is will be considered the number 1 carbon. And so I'll just pick this one. And ethyl is 2, so I'm going to put 1, 2. So this is my my second answer. And then I have 1,3-dimethyl cyclohexane. So let's draw it again here. So I have C, C, C. And if you take organic in college, you'll get really good at drawing this shape here. So 1, 3, it doesn't matter. If I put 1 here, that's my 1 position. And then I can go 2, 3, and that's my 3 position. It wouldn't matter if I put it here, 1 and 3. If I put it here, it would be 1 and 3. Whatever one of these would be first. And then just go in and fill in my hydrogens. He only needs 1, he needs 3, he needs 2, only needs 1, and 3. Write the structural formula for the following. So we have halogen derivatives now. So 2-bromopropane. Propane is 3, 1, 2, 3, and at the 2 position in the middle here, I have to put a bromine. Now, it's an ane, so everything else gets filled with hydrogens. Done. 1,4-dichloro-1-butene. Let's go to our root, but, which is 4. 1, 2, 3, 4. Butene, ene, tells me there's a double bond. So in this 1 position here, I'm going to put a double bond. Then I have 1,4-dichloro. So here's 1, and here's 4. Now let's fill in my hydrogens. This one needs 1, this one needs 1, this one needs 2, and this one needs 2. And then I have 1,3-dichlorobenzene. And so you'll learn more about benzene in your book when you do your reading, but benzene, a lot of times we draw even without the carbons in there. We draw it as a shape like this. Because what benzene is a special name for a cyclic hydrocarbon that has all double bonds. So we can say that in these spots here are actually carbons. And so let me draw it so that you can see it how you would do it. So you would do 1, 2, 3, 4, 5, 6, like that. And then let's put in our double bonds. 2, 2, 2. And then let's pick 2 here. So we have Cl and we have Cl. And then I'm going to go in. This guy has 4 bonds. This one has 3. This one has 4. This one has 3. This one has 3. This one has 3. But that structure that I just showed you, in benzene, it is fairly normal to leave out the actual carbons because it just gets complicated, and that's the more common structure you'll see for benzene. You can do either one, is fine. And then reactions with alkenes, we have addition reactions. So new atoms form single bonds to the carbons formerly involved in the double or triple bonds if it's reactions with alkynes. Examples, a hydrogenation reaction uses H2 as a reactant. So 1-propene reacts with hydrogen gas to produce propane. So propene, 1, 2, 3, it's 1-propene, so let's put that there. Let's give him 2 more hydrogens, 1 more, there. We're going to add hydrogen, H2, and it's going to produce propane. So 1, 2, 3, 1, 2, 3, like that. And a halogenation reaction adds halogen atoms. So we have 1-pentene reacts with bromine to produce 1,2-dibromopentane. So pentene, 1, 2, 3, 4, 5. We're going to put our double bond here at the beginning. Let's add in our hydrogens. 1, 2, 1, 1, 2, 1, 2, 1, 2, 3, plus bromine. And we will get, oops, 1, 2, dibromo, pentane, like that.